This video is a explanation of a concept for the design of a flying saucer engine, which is a cute way to say an engine that moves a vehicle in space forward based solely on internal forces within the engine, and that is opposed in principle to a rocket engine which moves a vehicle forward by discharging material out the back end of the engine. The flying saucer engine operates based on two proven scientific principles. One, permanent magnets have fields which apply forces at a distance. And anyone who's ever held a permanent magnet in their fingers knows that when you hold the magnets a distance apart, you can feel the force generated, either pushing the magnets further apart or pulling them closer together. The second principle of operation is that nothing can travel faster than the speed of light, and this includes magnetic fields. So if you turn on a magnetic field, then the field does not go out to infinity instantaneously. The field travels in a direction outward from the magnet at the speed of light. Similarly, when you have a permanent magnet in your hand and you point it in one direction and then you change and point it in another direction, the magnetic field does not go out in the second direction instantaneously to infinity. When you turn the direction of the magnet, the field goes in this new direction at the speed of light. So here is the basic mechanism that will be used for this engine. It's a platform with two permanent magnets attached, and as shown in this view here, the south pole of one magnet is facing the north pole of the other magnet, and therefore an attraction force shown by F is generated between the two magnets. Now, one other part of this engine operation is that these magnets can rotate. So we can flip them from the vertical position to the horizontal position, and both magnets can do this. So if we start the operation of the engine with the view shown here, with the left magnet being vertical and the right magnet being horizontal, then we flip the left magnet down to a horizontal position, what happens is that a force is generated on the left magnet, but no force is generated on the right magnet. Now this seems odd, but the reason for this is if we go back to our initial setup, the right magnet has a magnetic field which already extends all the way across to the left magnet. But the left magnet has a field which is going in the up and down directions and is not going towards the right magnet. So when we flip the left magnet to the horizontal position, it only feels the force from the right magnet pulling it towards the right magnet, but the right magnet has not received the electromagnetic field from the left magnet yet. So this is the instant that the magnet is flipped, it feels the force, and then it immediately starts sending its own magnetic field out towards the right magnet, and a little while later even more field goes out this way, and at some point we can flip the left magnet back vertical. That doesn't affect what's already been emitted. This chunk of magnetic field is still headed at the speed of light towards the right magnet, and when this magnetic field finally intercepts the right magnet, what happens is that a force is generated which pulls it towards the left magnet. And after the magnetic field has passed, then what we get is this situation where there is no force on either magnet again. Now this device has already moved the platform to the right, because the left magnet felt a force to the right first and was not balanced by a force from the right magnet. So the platform started moving to the right, and then when the magnetic field finally reached the right-hand magnet, a force in the opposite direction was generated, which slowed the velocity of the platform back down to zero. So if we're clever, we can arrange the flipping of these magnets to do even more than what we've seen here. So we go back to our starting position where the left magnet has flipped in the horizontal position and is feeling the force from the right magnet. The field starts going outward while the left magnet still feels its force. The platform mechanism is accelerating to the right. It's still accelerating to the right. The magnet is still feeling the force. Then the left magnet is put in the vertical position. The magnetic field is headed towards the right magnet, and the platform now has a constant velocity to the right. Still has a constant velocity to the right. And now we have flipped the right-hand magnet so that the south pole is facing the south pole magnetic field that has already been generated. And what this means is that when the magnetic field strikes the right-hand magnet, a repelling force is now generated, and this repelling force pushes the right-hand magnet to the right. Well, the left-hand magnet has already pulled the platform in a direction to the right, and now by flipping the right-hand magnet, we can generate a second force pushing the platform to the right. And this continues until this little chunk of magnetic field goes past the right-hand magnet. So it almost looks like we can create some kind of a cycle here that could be used continuously to keep generating forces to the right. And that's what we're going to do. We're going to start with the magnets in this position where both are vertical. Now we'll flip the right-hand magnet down to a horizontal position, north pole facing left. And now the north pole magnetic field starts moving towards the left-hand magnet. Now here the right-hand magnet is once again vertical, so we have a chunk of magnetic field going towards the left. This continues for a while and a while longer. Now the left-hand magnet is flipped so that the south pole is facing the north magnetic field, and this generates a force to the right, which we have already covered. And as the force continues, the south pole from the left magnet is now starting to flow towards the right-hand magnet, and this flow continues until the left magnet is flipped vertically, and now we have a chunk of south pole magnetic field headed towards the right-hand magnet, and it keeps going in that direction. And just at the wonderful time necessary, the south magnetic field strikes the rotated position of the right magnet, generating the repelling force which pushes the platform again to the right. And this continues. Now the right-hand magnet's generating its own south magnetic field, which is headed back left. Now the platform is more or less in the starting position. We can see that we've created a cycle here, that we could just keep flipping these magnets indefinitely back and forth and generating a steady stream of forces, all of them going to the right, to continue to accelerate this platform to the right for as long as we desire. In other words, we can see that what if the magnets were not flipping instantaneously? What if they were just rotating at a constant velocity? You would still get some effect. And in fact, we can generate an equation that shows this effect. We show the Gilbert model here for the magnetic force between two permanent magnets. The force F is equal to the permeability divided by 4 pi, and Q is the magnetic pole strength, L is the distance between magnets. Using this model for our magnetic engine, what we find is that if the constant rotation velocity of the magnets, which is shown here by omega, if that velocity equals pi times c, the speed of light, over 2L, L being the distance between magnets, then the average force on the mechanism while the magnets are spinning, now they have to be phased, out of phase by 90 degrees, but as long as one magnet is vertical when the other magnet is horizontal, we get this effect of the engine operating, and the average force generated in that case will be what you see there, U Q squared over L squared, which is just the force felt on one pole of the magnet by the Gilbert model of magnetic force. Now it should be mentioned that this engine does appear to violate the law of conservation of momentum, and that's a serious issue. However, it should be noted that the law is not derived from a higher law. There is a law of conservation of momentum strictly because people have never ran a test that violates this law. So people just say, well, it must be a law because we've never found a case where it's been violated. But as science continues to advance forward and we learn new principles, such as a magnetic field cannot travel faster than the speed of light, then we get more of a possibility that the law of conservation of momentum could be broken, and you could design an engine which thrusts a vehicle forward based purely on its own internal operation and not having to rely on ejecting material away from the vehicle. And as of this point, the engine in this video has not been experimentally tested, and of course further analytic work needs to be done, but this is the concept that is involved in the operation of this engine.